Right, question 7, find dy dx for y equals 7 arc cosecant 4x. This is asking us to find the derivative. I know that the derivative of arc cosecant is negative du over the absolute value of u times the square root of u squared minus 1. My u is going to be 4x. The 7 is going to hang out for the right. So if I take the derivative of this, the 7 is just going to tag along. Negative du, so it's going to be negative, the integral of, or the derivative of u will be 4, and then over u, which will be 4x, and then square root 4x squared minus 1. And now we're going to clean this up. If I put a 1 underneath the 7, up top, 7 times negative 4 is negative 28. And then on the bottom, couple things I'm going to do. This first thing that I'm going to do, since 4 is inside of the absolute values, the absolute value of 4 is just 4, so I do not need the 4 in the absolute values, but the x is going to stay in the absolute values. And then square root, if I take 4x and I square it, that will give me 16x squared minus 1. And then my final step, to get dy dx, I'm going to reduce negative 28 over 4 would reduce to negative 7 over the absolute value of x times the square root of 16x squared minus 1. Okay, question 8. Find the derivative of arctan e to the x over 2. So in this problem, since I'm dealing with arctan, I know that the derivative is du over 1 plus u squared. So in this case, u will be e to the x over 2. So if I'm finding the derivative, rewriting this would really be like e to the 1/2 x. So I do know the derivative of e to the u is just e to the u du. So this is going to be e to the 1/2 x times 1/2, and then all over 1 plus u squared. So 1 plus e to the x over 2 squared. And then just cleaning this up a little bit. 1/2, when I multiply this by 1/2, it's really going to be like I'm going to have e to the 1/2 x over 2 times the quantity 1 plus. When I take e to the x over 2 and I square it, you're going to multiply the exponents. So when I take x over 2 times 2, that's just going to give me x. And then if I wanted to rewrite that, I could rewrite that as e to the x over 2 quantity 1 plus e to the x. And hopefully that made sense. The 1/2, since it was a fraction, the 2 could just go down on the bottom with the other stuff that was down on the bottom. Okay, question 9. Find the exact value of the arcsecant of -2 and the arctangent of 1. Okay, first of all, I know when we're dealing with arcsecant, I like to change it to arc cosine. And if I change it to arc cosine, I need to take the reciprocal of what's inside, which will be -1/2. Now please remember, on these problems, we're trying to think the cosine of what angle will give me -1/2 as an answer. So first of all, let's think of where it's going to equal. I'm going to do a unit circle here. Let's think of where it's going to equal -1/2 or just 1/2. If I'm using my fingers or however you want to use it, the cosine is the stuff above. So I know that the value that will create a 1/2 is going to be pi over 3. And if I'm looking for where does the cosine equal a negative value, those would be the x values, which would be, my x would be negative down here, and my, and over here. Those would be my x values. So that would happen at 2/3 pi, and then again at 4/3 pi. And if I'm thinking about the domain of cosine, I know domain of arc cosine is just this part of the unit circle, so 2/3 would be my only acceptable answer. Okay, arctangent of 1, I'm looking again for where does the tangent equal 1, and for this would be the sine of what over the cosine of what would this answer equal 1. So I would like to know, when sine is the y value, cosine is the x value, where do both the sine and the cosine equal the same thing so that it would equal 1? And I know that that would happen when I have the square root of 2 over 2 for both of them, and that occurs at pi over 4. And the other place that would occur where they're both positive, or would they be both negative, would actually be at 5/4 pi. And since I'm dealing with arctangent, I know arctangent goes from -pi over 2 to pi over 2, so pi over 4 would be my acceptable answer for that one.